Today we're looking at an example of solving simultaneous equations. The question states, Tom rides his bicycle from town A to town B at an average speed of 20 kilometers per hour. Julia walks from town B to town A along the same road at an average speed of 5 kilometers per hour. The distance along the road between the two towns is 15 kilometers and they each start off at the same time. Part A asks, write two linear equations to model the two journeys. In each case, relate the distance in kilometers from town A to the time travelled in hours. It's important for this particular question to know the speed formula. So speed is calculated by distance over time. You can also simplify that as S equals D over T. So we're going to use this to be able to develop our two linear equations. So the first one I'm going to look at is Tom. So Tom rides his bike from town A to town B at an average of 20 kilometers per hour. So he goes from town A to town B with a speed of 20 kilometers per hour. So if we used our speed formula, so Tom's speed equals distance over time, we can substitute Tom's speed of 20 kilometers per hour into this formula. So 20 equals D over T. However, the question actually asks us to relate it in terms of distance. So we want this formula in terms of distance. So all we're going to do is rearrange our formula. So D equals 20T. So for Tom, this is his equation on how he is travelling along this road. For Julia, however, she travels from town B to town A at an average speed of 5 kilometers per hour. So she's actually going from B to A at 5 kilometers per hour. So if we used Julia's speed and we place it in our speed formula, do 5 equals D over T. But again, like it says, we need to do it in terms of distance. So if we rearrange our formula, we will have D equals 5T. Now, just to make things a little bit more complicated, what the question asks is, relate the distance in kilometers from town A. Now, unfortunately, Julia is starting from town B, which is 15 kilometers away. Okay, but we want to actually do it in terms of starting at town A. So her formula is a little bit different. So her formula will actually be D equals 15, because she still needs to travel that 15 kilometers, take away the speed that she's traveling at, because that's going to tell us how many kilometers she's traveling along that road to get to town A. So her formula is actually D equals 15 minus 5T. Now for this particular question, it's really important to remember this one and this one to begin with, but I don't want you to forget that one just yet. But in terms of writing two linear equations to model the two journeys, in each case relate the distance in kilometers from town A to the time travelled in hours, these are the two that I've just circled that are important. So Tom's is D equals 20T, that models his journey, and D equals 15 take away 5T models Julia's journey. So solve the equation simultaneously using a graphical method to find the time at which they meet along the road between the two towns. Now, you could either create a table of values where you substitute values into that formula and you create one table, you plot those points onto a coordinate plane and join those lines, and then do another table of values for this particular formula, and same thing, plot those points on a coordinate plane and join the lines. The other way is what I've done here just to save time, is to use the online tool that we've got. So as you can see, I've got my two equations there, and I've plotted the two different lines. So the green line is Tom's journey and the purple line is Julia's journey. So the question asks to solve the equation simultaneously using a graphical method. So what we want to know is the time at which they meet along the road. So we want our T value, okay? And we want it in terms of that point of intersection, which is right here. Now, if you actually looked at the equation and you use the online tool, you can actually place your cursor on there. And what it will say is 12, 0.6. So our t value is 0.6 hours. Or if you converted that to minutes, that would be 36 minutes. So they would actually meet on the road between the two towns after 36 minutes from the time that they left their respective towns. Part C says, how far has each travelled before they meet? So what we want to do is find out the value of D for both of them when t equals 0.6. So what we're going to do is substitute t equals 0.6 into each of their formulas. So first we're going to do Tom. So Tom's formula, if you remember, is D equals 20t. So I'm going to substitute t equals 0.6 into this formula. So 20 times 0.6, and that will get me 12 kilometres. So he has travelled 12 kilometres along before they meet, so that before that point of intersection. If you look on our graph, you can actually see that it actually is at 12 as well. Okay, so you can also use the graph if you'd like as well. Now Julia, we're not worried about whether she's starting from town A or B or the distances or anything like that. We just want to know, in terms of her speed, how long will it be before, or how far will it be before they actually meet together. So instead of using that really long formula, we're actually just going to use the simple speed formula. So because we don't need to worry about that she's not starting at the same place as Tom. We just want to know in terms of speed. So again, we're going to substitute t equals 0.6 in here. So 5 times 0.6, and then you can see d equals 3 kilometres. So that tells me that Tom has travelled 12 kilometres and Julia has travelled 3 kilometres when they actually meet at that point of intersection. And again, you can kind of read that off the graph as well, but using algebra will give you a lot more of an accurate answer. So in terms of creating these simultaneous equations, it was important to know the speed formula. It was also important to really read into the question, especially when it talked about starting from town A and also then starting from town B, which can really affect the formulas that you get. And then obviously we need to make sure our graphs are drawn accurately, but we can always use algebra to check or to actually get a more accurate answer.